In this video, we're given a right triangle and we're given two of the sides and we have an angle that's designated with x and we want to solve for x. And the strategy we're going to use is we're going to look at our sine, cosine, and tangent and we're going to try to figure out which one of these trig equations is going to relate what we know out of this given triangle to what we're trying to find. Now, the main thing to notice in this problem is that we're looking for an angle, and so this is going to be something that we haven't quite done yet. Any of the other videos I posted, we just found other sides, but we're still going to use the sine, cosine, or tangent, whichever one we need. So let's go ahead and figure out, we're looking for angle x, and so 17 in terms of angle x is the opposite, so we can write an OPP right here if we want to for opposite, and the 20 of course is the hypotenuse, because the side that is opposite the right angle is always the hypotenuse. And so now we want to figure out which one of these trig equations is going to relate the angle x, and that'll be in the place of theta, with the opposite and the hypotenuse. And so our answer is sine theta. And so now what we're going to do is we're going to go ahead and set up our equation. And so we know sine theta, but our angle this time is x. So sine x is going to be equal to x's opposite over its hypotenuse, which is going to be 17 over 20. And so now we have an x value that we're trying to solve for stuck inside of the sine, and so we need to get rid of sine. And so to accomplish that, what we're going to do is we're going to take the sine inverse of both sides of this equation. And so the sine inverse of the sine x is just going to cancel out because we're just dealing with a triangle, so our angles are going to fit right. And then the sine inverse of 17 over 20 is going to be something we can turn to the calculator for. So like I said, our sine inverse sine cancel, and that's just going to leave us with x on the left-hand side. And that's going to be equal to the sine inverse of 17 over 20. And again, what you probably want to do when you're solving this problem, or a problem like this, and you're looking for an angle given a right triangle, probably the best thing to do is to get your answer in degrees, because that's going to be the nicest way of expressing your answer. If you do it in terms of radians, you're going to get some sort of decimal answer. It's not going to be in terms of pi, so it's not very nice, and it doesn't give you a good idea or conceptualization about how large that angle is. And so be sure that your calculator is in degree mode for this, and you just want to type in sine inverse 17 over 20 and then close your parentheses. Be sure the whole 17 over 20 is in parentheses. And when you do, you get approximately, and of course this will be rounded, 58.2. It's like 58.21166,938, and it probably keeps going. But you can probably just go to one decimal place when you're finding angles on here unless Alex tells you otherwise. And so that's our angle x. So now that we know angle x is 58.2, we're done with this problem. But if the problem pushed us to figure out what the other angle was, then we could just either use another trig, equation that would find that angle in terms of that angle, by finding what it would be its adjacent over its hypotenuse. And so we could just name the third angle. But another easier way to do this is we know that all of the angles in a triangle add up to 180. So if you ever know two of the angles, you can just subtract those two numbers from 180, and that'll tell you the value of the third angle. Also, if we needed to solve for the third side, we could use the Pythagorean theorem, or we could use any of these trig equations as well. But for this problem, all we have to do is solve for x. There's no reason to make it complicated. 58.2 is our answer.